The problems in this video are from ES5, the LT3 section of the review. I'll be working problems 25, 27, 33, and 35. If the problem that you are having trouble with isn't one of these, I suggest you watch the video anyway, especially any problems that appear that they might be similar to the one you're working on. Number 25 asks us to solve. This is a logarithmic equation, and at this point it says log on the left side, and there's just a number on the right side. That means that I have to change forms because there's nothing I can do at this point. We're going to look at this problem a couple ways. So we're going to start with this method that I just mentioned. So that means we'd have x to the third power equals 8. Now, many of you would recognize that what we could do here is cube root both sides at this point. So we get x equals 2, which is true. Another way we could do this problem is just to use what we know about logarithms, that x is the base of the exponent and 3 is the exponent. We've done 2 cubed many times in this class. So a lot of you looking at this equation in the new form, x cubed equals 8, I hope without cube rooting both sides you just realize, oh, x has to be 2. Okay, so if you just wrote at that point x equals 2, that would be fine. The next problem is another logarithm, and I chose this problem because the descriptor has an exponent, and I thought that might be tricky for you. So the first thing I would do here, again, it only says log on one side, so I would change it to exponential form, which, sorry, this is skipping here. So I get 3 to the 12th power equals x to the 6th power. Now, it would be okay if you used your calculator and took 3 to the 12th power and got that number, and I'll show you that method in a minute, but I want to show you something that would be a little easier, actually. We know that 12 is 6 times 2, and since 12 is the exponent, we could rewrite this as 3 squared to the 6th power equals x to the 6th power. We know that when we multiply exponents, or that when we raise a power to a power, we multiply the exponents and get 12. So we could work backwards from that to get from here to here. Now that's not something we've done in class before, but I think you can see how they would be equivalent. So since 3 squared to the 6th power equals x to the 6th power, x must equal 3 squared, which is 9. So that would be one way to do that problem. The other way to do that problem is to say 3 to the 12th equals x to the 6th. Put 3 to the 12th in your calculator and you get something like 531,441 equals x to the 6th power. Then you could take the 6th root, and I'll remind you of how to do that in your calculator here in just a second, which would give us x equals 9 once again. So in your calculator, how do you do that? I hope you can see this all right. To do the 6th root on your calculator, figure this out. First you take 6, and then you go to math, and then number 5 here says the xth root of something, so we use number 5, and it made it the 6th root, and then 531,441. And we get our answer of 9. So that's how you do that 6th root in your calculator. The next problem, number 33, is also a logarithm problem. These both have a base of 10. So since they both have a base of 10, the descriptors must be equal. The log base 10 of this descriptor equals the log base 10 of this descriptor. So I can say, well, if that's the case, using that equality property, x minus 1 squared must equal negative 5x minus 1. Now I just have a quadratic equation. So I'm going to square x minus 1. And I just can't emphasize enough times that make sure you square the binomial. So we get x squared minus 2x plus 1 equals negative 5x minus 1. So now I'm going to take this and I'm going to add 5x to both sides. And I'm going to add, I'm going to add 1 to both sides. So I add 5x to both sides, and I add 1 to both sides, which gives me x squared plus 3x plus 2 equals 0. Now I'm going to factor this. It's going to be x plus 2 times x plus 1. And I knew that because 2 times 1 equals 2, and 2x plus 1x equals 3x. So I'm going to set those factors equal to 0, and I get x equals -2 and x equals -1. So I do need to check those solutions, and I'm going to begin by putting in -2. So when I put it -2 into the left side, change colors here, I get -2 minus 1 squared, and I am putting this into the log, I'm sorry, of -2 minus, that's very sloppy, that bothers me, I'm sorry, I'll erase that, make it better here. All right, here we go. So we have the log of negative, evidently this doesn't like this, here we go, -2 minus 1 squared equals the log of -5 times -2 minus 1, which gives me the log. -2 minus 1 is -3, but when I square it I get 9, so I still get a positive descriptor, so that's okay. And over here I get the log of -5 times -2, which is 10, minus 1, this is all together, which is 9. So that one checks. -2 works. Now I put in -1, same way, the log of that's the parentheses, -1 minus 1 squared equals the log of -5 times -1 minus 1. So this on the left is the log of -2 squared, which is 4. And on the right, I have the log. -5 times -1 is +5, minus 1 is 4, equals the log of 4. So both of those solutions work just fine. Don't ever assume that just because your solutions are negative that they're extraneous. It's only if they make the descriptor negative, and neither one of these did. Our last problem is number 35. You need to read this problem on your review. I'm not going to read it aloud to you, but it's about the pressure in the lower stratosphere. And it asks, it defines the variable saying P is atmospheric pressure in pounds per square foot, and the H is height, it being altitude. So it's asking the pressure, the height, when the pressure is 150 pounds per square foot. So I'm going to put 150 in for pressure. And notice this is 0.1, 472.1 E, and all of this is the exponent, 1.73 minus 0.00048 H. And all of those zeros are important. So don't think, oh, I can just round that. That would be a bad idea. So at this point, notice that here's the base of my exponent is E, not the 472. And of course, the exponent is all of this up here. So 472.1 is what I'm multiplying times this E to this power. So to get rid of that, I want to divide by 472.1. These are just numbers, so it's just like when we've solved any of these before. So 150 divided by 472.1 is about 0.3177 3. Now notice I'm using more than 3 digits here. I'm doing that because these numbers are very, very tiny. And some of you may remember from that video we watched the first day that logarithms and exponential functions are a way of dealing with very small and very large numbers. So here's some of those very small numbers. Now I'm down to a basic exponential equation, and I want to solve for h. So since I just have a base with an exponent on the right and a number on the left, I'm going to change to log form. Since the base of the exponent is e, this is log base e. Now I could have written there ln. So I was just writing log base e because I thought it might make it easier on you. Of 0.31773 equals my exponent of 1.73 minus 0.000048 h. That's a 0. So now that I'm here, I'm going to subtract 1.73. That's a lie. I'm going to subtract on the right 1.73 minus this. No, not that. This is an h down here. There we go. Okay, so now that I'm here, I'm going to subtract 1.73 from both sides, which I think, oh, that was silly. I need to, on the left, evaluate the log base e of 0.31773. So that's just, in your calculator, it's ln, and you put that number in. And when you do that, you get negative 1.1466. So this equals this, and you just get that number from your calculator. I could do that for you real quick here. So it's the natural log. Let me turn this on here. The natural log of 0.31773. And that gives us this negative 1.147, which I guess I put 6, so I'll change it to 7 because I just decided and rounded through it. Okay, 7. Okay, so now we subtract the 1.73, which gives us 0.437 equals what's remaining over here, negative 0.000048 h. And I hope you see, since we're solving for h, now we just divide both sides by negative 0.000048. And that gives me h equals 59,929 feet. If you look back in the problem, it said that this was good in the lower stratosphere, which is between 36,152 feet and 82,345 feet. And we see that our answer does fall within that range, so that's kind of a little double check that you must be right. And that's our answer. That's the end of this video.